Welcome to a deep dive
Okay.
into the way people a century ago were first starting to figure out the whole human mind thing.
Right, right.
We're going to be looking at Elementary Experiments in Psychology,
Okay.
which is a 1909 book by Carl Seashore,
Uh-huh.
who was like this huge figure in experimental psychology.
Yes.
And this book was actually a guide for students to run their own psychology experiments,
Okay.
even if they didn't have like a lab or anything.
That's pretty cool.
Yeah, so it's like a DIY psychology kit from 1909.
I love it's fascinating to see how he uh basically like democratized this whole study of the mind.
Yeah.
You know,
Yeah.
brought it into people's homes.
Yeah, exactly.
Yeah.
So what kind of experiments did he have people doing back then?
Um well, he covered all kinds of stuff.
Okay.
Really a wide range of sensory perception.
Uh-huh.
We're talking everything from visual illusions,
Yeah.
like the after images you see after you've been looking at a bright light,
Right.
to understanding how we figure out where sounds are coming from, and even down to like how sensitive different parts of our skin are.
Oh, wow.
Yeah.
That's pretty interesting.
Yeah.
So let's actually start with those after images.
Sure.
I remember learning about those in school, but I feel like there's probably a lot more to it than I realized.
Oh, yeah, definitely. There's more to them than meets the eye.
Yeah, all right.
One of the experiments in the book has you projecting a black square
Okay.
onto different backgrounds. So you use a white background, a gray background, and a black background.
Got it.
And you just look at how this changes the after image you see.
Okay.
And the interesting thing is that the after image is way more vivid
Yeah.
when it's against that dark background.
Oh, really?
Yeah.
So is that just because of the contrast?
Well, contrast is part of it, but there's actually a deeper physiological reason.
Okay.
It has to do with the fact that the dark background, it minimizes all those other light signals that are hitting your eyes.
Mm-hmm.
So it's kind of like how stars look brighter on a dark night.
Right.
Yeah, it's the same kind of thing.
Oh, I see.
Yeah.
So it's not just that our brains are like cameras, passively taking in information.
Right.
It sounds like they're actively filling in information.
Exactly.
Kind of the context.
Yeah, and that idea of context, really shaping how we perceive things,
Right.
it becomes even more clear when you look at color contrast.
So those optical illusions where colors look different
Exactly. Those.
depending on what's around them.
Yeah, precisely. And Seashore, he demonstrates this
Okay.
using gray bars
Uh-huh.
and putting them in different colored backgrounds.
Got it.
And instead of looking gray,
Yeah.
they actually look like they're tinged with the complementary color of the background.
Oh, wow.
So it's like our brain is overcompensating
Yeah.
for that background color,
Yeah.
and it leads to this illusion.
Okay, that's so cool. I mean, I could see how artists might use that kind of effect, in their work
Yeah.
to create different moods or highlight certain elements. Yeah.
To make things pop.
Right,
Yeah.
right, exactly. But for the rest of us who aren't painting masterpieces,
Sure.
what's the main takeaway here?
Well, I think the big takeaway is that how we see color isn't absolute.
Okay.
It's always being influenced by what's around it, by that context.
Yeah.
It makes you wonder, what other perceptual shortcuts
Right.
our brains are taking without us even knowing.
That's such a good point.
Yeah.
So moving on to another aspect of visual perception,
Okay.
Seashore also talks about the visual field
Right.
and how we see things in our periphery.
Yeah.
So he uses this tool called a perimeter,
Uh-huh.
which is actually pretty simple
It is,
to
yeah.
measure a person's indirect field of vision.
Right.
And what it reveals is that color vision isn't evenly distributed
No, not at all.
across our visual field.
Yeah.
So so we don't see color as well in our peripheral vision.
That's exactly right.
Wow.
Yeah, the center of our visual field is packed with these cells called cones that are responsible for color vision.
Okay.
But then as you move out towards the edges, the number of cones drops off,
Uh-huh.
meaning we're getting less color information from those areas.
That's fascinating. Is there an evolutionary reason why we would have sacrificed
Good question.
peripheral color vision?
Well, there's a theory that it's connected to the development of color vision itself.
Okay.
Being able to see color really clearly in the center
Yeah.
was super important for things like finding ripe fruit
Right.
or spotting predators.
Yeah, that makes sense.
Whereas peripheral vision, that was more about detecting movement,
Okay.
which is key for knowing if something is coming at you.
Right. So it's like a trade-off then.
Yeah, exactly.
Better motion detection in exchange for less peripheral color.
Makes sense when you think about it that way.
Yeah, definitely. So it highlights how our brains prioritize
Right.
different types of information depending on the situation.
Exactly. Yeah.
That's really cool. Now, are you ready to shift gears a little bit?
Sure. Because Seashore also dives into the world of auditory perception,
What?
particularly how we locate sounds in space.
All right.
I'm all ears.
Okay, good one. Tell me about these auditory space experiments.
So one of the experiments involves a blindfolded listener,
Okay.
and they have to try to figure out where clicking sounds are coming from.
Got it.
And these clicks are made at different positions around the listener's head,
Okay.
which you'd think would make it pretty easy to figure out.
Right. Yeah, you would think so.
You'd think so,
But how do people do?
surprisingly, only about 10% of the time could they accurately tell where that click was coming from.
Wow, only 10%.
Yeah.
So, like, what other factors are at play then when we're trying to figure out where a sound is coming from?
Well, Seashore points to things like mental imagery and our past experiences.
Okay.
You know, we tend to associate certain sounds with certain locations.
Right, like a doorbell always coming from the front of the house or something.
Exactly, and those kind of mental shortcuts, they influence our judgment.
Interesting. So it's like our brains are creating
Yeah.
a mental map of where sounds should be coming from
Uh-huh.
based on what we've learned.
Based on what we've learned, exactly.
So cool.
Yeah, and again, it highlights the fact that perception isn't just like passively taking in information.
Right.
It's actively interpreting it
Yeah.
based on our expectations,
Right.
our memories, even our biases.
This is incredible. We've gone from, trippy visual illusions
Uh-huh.
to how our brains make sense of sound.
Yeah.
What else did Seashore cover in this DIY psychology journey?
Well, Seashore didn't stop there.
Oh,
He also wanted to explore our sense of touch.
okay.
So one experiment he describes focuses on this thing called the 2-point threshold.
2-point threshold?
Yeah.
Remind me what that is again?
Basically, it's a measure of how sensitive your skin is.
Okay.
It's like the minimum distance between 2 points that you can still feel is like 2 separate touches instead of just one big one.
Oh, right. So he had people testing this out on different parts of their bodies, right?
Exactly.
Did he find anything interesting?
What's really cool is that this 2-point threshold, it varies a lot
Yeah.
depending on where you are on the body.
Okay.
Like you can tell 2 points apart that are super close together on your fingertips,
Uh-huh.
but you need them to be much farther apart to feel them as separate on your back, say.
Right. Makes sense. Our fingertips are like
Yeah.
finely tuned instruments, practically.
Right. They're so sensitive.
So is that because there are more nerves concentrated there?
Exactly.
Yeah.
Fingertips just have a way higher density of nerve endings
Got it.
than other areas. And that's where they're so good at like
Yeah.
fine motor skills and
Yeah.
picking up on different textures and all that.
It's like evolution gave us the perfect tools for interacting with the world.
Right. It's pretty amazing.
It is. But this idea, like different levels of sensitivity,
Yeah.
does that tie into any bigger ideas in psychology?
Absolutely. It actually leads us to one of the foundational principles, Weber's law.
Oh, Weber's law. I always struggle to remember
Yeah.
how that works exactly.
Yeah.
Could you give me a refresher?
Sure. So basically, Weber's law says that the just noticeable difference
Uh-huh.
between two stimuli
Okay.
is proportional to the size of the stimuli.
Okay. Can you give me like an example to make that a little clearer?
Okay, imagine you're holding two weights.
Okay.
One's 10 grams, the other's 11 grams.
Got it.
And let's say you can barely tell the difference between those two.
Okay.
Weber's law says that to notice that same level of difference,
Yeah.
you would need 20 grams and 22 grams.
Oh.
So you see, the ratio stays the same,
Yeah.
even though the actual weight difference doubled.
So it's not about the absolute difference of 1 gram.
Right.
It's about the proportion that's fascinating.
It is. And Seashore demonstrates this with an experiment where people compare a standard weight to a slightly heavier one,
Got it.
and they have to judge the difference.
Okay, and I'm guessing the results showed that our perception of weight isn't as straightforward as we might think.
Exactly. It all comes back to that ratio.
Wow. That has huge implications for how we think about not just weight, but all sorts of sensory perception.
Absolutely.
It's amazing to me how these simple experiments can reveal such deep insights into the way our brains work.
It's true.
We've covered visual illusions, sound localization, tactile sensitivity.
Yeah.
Is there a common thread running through all of these different areas of perception?
I think the big takeaway is that our brains are constantly shaping our perception of the world.
Okay.
You know, it's not like we're just passively absorbing information.
Right.
We're actively making sense of it.
Yeah.
Using context, past experiences,
Yeah.
even our own biases.
It really makes you realize how much is happening
Yeah.
below the surface of our awareness.
So much.
It's like our brains are master illusionists,
I like that.
creating this seamless experience out of all this sensory data that's bombarding us.
That's a great way to put it.
And like understanding these perceptual mechanisms is like getting a glimpse behind the curtain to see how the magic trick works.
Exactly.
Yeah, it is pretty humbling to realize how much our brains are kind of like filling in the gaps and creating these illusions.
It is.
But I guess in a way it's also empowering because if we understand how those illusions work, then we can start to see through them, right?
Absolutely. By becoming aware of these processes, we can be more conscious of how our brains are maybe shaping our experiences.
Yeah.
And that awareness can help us make better judgments about the world around us.
Right. So it's like having a decoder ring for reality.
I like that.
But before we wrap things up, I wanted to touch on the historical context a little bit.
Sure.
It's pretty amazing to think that Seashore was doing these experiments over a century ago.
Yeah, it's really a testament to his vision. At the time, psychology was a pretty new field. And Seashore's work, especially this book, it really helped make psychology popular and accessible to more people.
So he was like a pioneer in a way.
Absolutely.
Taking psychology out of the lab and putting it into the hands of everyday people.
Exactly. And his focus on experimentation really helped establish psychology as a real science.
Right.
It's fascinating to see how his work kind of laid the groundwork for so much of what we know about the mind today.
Okay, so as we kind of come out of this deep dive into early 20th century psychology, what is like one final thought that you want to leave our listener with?
Well, I would encourage them to think about all the different ways that perceptual illusions and biases might be affecting their own everyday experiences.
Okay.
From how we see colors and hear sounds to how our brains understand touch.
Yeah.
There's a whole world of unconscious stuff going on.
Right. It's a real challenge to try to question our own assumptions and see these hidden patterns.
It's hard work.
But it's also what makes exploring the mind so fascinating, right?
I agree completely. And at the end of the day, that desire to understand, that's what psychology is all about.
Well said. Thanks for taking us on this deep dive.
My pleasure.
It's definitely given me a whole new perspective on how my brain works.
Glad to hear it.
And to our listener, keep those decoder rings handy and stay curious.